Hi, linear algebra students. So I think this video will be quite short because the only thing I'm really doing here is giving giving a warning that the invertible matrix theorem works only for square matrices. In other words, it doesn't apply at all for matrices that are not square. So like whenever you are dealing with non-square matrices, you have to completely forget about the invertible matrix theorem, and the appropriate theorems to use are the pivot theorems. So again, this is the second video of the makeup classes on the invertible matrix theorem. So please either have page 1 printed or follow along with textbook page 114. Okay? And this is the example. What I want you to notice is that if you look at the columns here, so let's label them A1, A2. So A1, A2, okay? They are linearly independent. So A1, A2, okay, is linearly independent, which means that the statement, I think it's E of the invertible matrix theorem is true. So E is true. Okay, and again, they are linearly independent since they are not scalar multiples. Let's actually just erase this and because again, like I want you to explain that to me. Since they are not scalar multiples. You could also say that this is a row echelon form. So, oh, it's not a row echelon form. Okay, be careful. So since they are not scalar multiples, okay, which means that statement E is true. However, okay, if you row reduce this, so you have like 1, 2, 3, 4, 0, 5, okay, or actually you don't even need to row reduce it. So, however, the columns A1, A2. So the set of these two columns doesn't span our tree. And this is because it cannot have a pivot in every row. So since it can't have a pivot in every row. And this is because you have more rows than columns. So which means that by the row pivot theorem, it doesn't span our tree. Okay, so in other words, it means that well, that's it. Actually, you don't need to invoke the row pivot theorem here, but let's just keep it in mind. Like what we're using here to answer the question is the row pivot theorem. So what it means is that the statement, and I think it is H. So statement H is false. All right, that's it. So I'm just going to repeat my point. Don't use the invertible matrix theorem at all if you are not sure that your matrix is square. This is a frequent mistake that I see. So if the matrix is not square, you have to fall back on the pivot theorems, which are the blocks of building up the invertible matrix theorem when a matrix is square. All right, see you around next video.